Welcome to my virtual past session on getting the most out of Dax Studio. My name is Darren Gosbell and I'm the primary author of the open source tool Dax Studio, and I'm here today to help you getting the most out of it. So let's get into it. Before we go any further, let's make sure that everyone's had a chance to explore everything Pass has to offer. There's a bunch of benefits from being involved with Pass, from being a pro member down to getting involved with your local user group, being involved with SQL Saturdays, virtual groups, volunteering, the Pass marathons. There's a bunch of great stuff that Pass does in the Microsoft data platform space. I'm based in Melbourne, Australia. I'm actually the leader of the local Melbourne Pass chapter, which is the Microsoft Data Platform user group. We talk about everything from Power BI to SQL on-prem to SQL Azure to all of the Azure services. So if you're interested in any of the data platform content, be sure to sign up to that. I'm also involved in the local Pass SQL Saturday events. Unfortunately, we haven't been able to have one this year due to the pandemic restrictions, but as soon as that those things are lifted, we're looking forward to getting back and getting in contact with everyone. Your feedback is definitely important to us. As a presenter, that's how we get better, making sure that the presentations we do are high quality and target things people are interested in, and there's also a plus from your point of view because your feedback enters you with the chance to win a prize. So it's sort of a win-win situation there. I've been in the Microsoft space for over 20 years now. I first came involved with the very first version of what was OLAP services, which was the original multi-dimensional engine and MDX, and I've sort of transitioned into Tabular and DAX, and hence the Dax Studio project. I'm currently the Business Intelligence Manager at Metro Trains in Melbourne. So we deal with all of the Metropolitan Train network, which is very interesting area to be involved with. I've been a Microsoft MVP for 15 years, since 2006, and I'm quite heavily involved in, as well as the local user group, I tend to jump on the Power BI forums, and I contribute to a number of open source projects, including leading Dax Studio and the BI developer extensions, which many of you may have known as Bids Helper back in the past. This session is about Dax Studio, so I thought I'd show a few brief slides at the start, and then everything else from there on is demos. So just a quick couple of slides of an overview. So what is Dax Studio? So the original idea for Dax Studio actually came out from a discussion I had with some of the product team. When the Tabular engine was first introduced, it was just a Power Pivot external add-in to Excel 2010, so you had to download it separately and install it. And you had the little model designer, a sort of a early version of what we're familiar with now in Power BI, and you had the measure editor, but you could only query those measures with pivot tables, which queried using DAX. So it seemed strange to me at the time that Microsoft had built a language that was queried through another language. When I talked to the product team about it, they said, "Oh no, we've got plans beyond that. It's a full-blown query language, not just a language for writing measures. You can execute queries and get results back using evaluate." So that sort of led to what became the original version of Dax Studio. So originally it was an Excel add-in that used to talk to the Power Pivot add-in. But then as the data engine grew and expanded into more places, so it first went into analysis services on-prem, and then Power BI and Power BI Desktop and Azure analysis services, Power BI Premium. So Dax Studio can connect to all of those things, and Dax Studio evolved, and it's now, as well as being an Excel add-in, it's also a standalone program in its own right, and I think that's the way most people use it nowadays. Is they tend to connect to Power BI or analysis services and use DAX Studio that way. So I know this is a bit of a busy slide, but if you look at the center here, this blue box represents DAX Studio. At its core, DAX Studio uses a couple of Microsoft libraries, the AMO or TOM library now, and ADOMD.NET. And all we do is we send a query or trace event, trace requests to whatever data source you want to connect to, and we support all of these different data sources. And then we get the results back, either event traces or query traces. We'll have a look at those. And they come back in and we show them typically on screen, although you have the option of exporting to CSV and text file. And just recently we added native support for Excel exports. Previously that was only available in the Excel add-in because we could talk directly to Excel, but now we can push straight out to Excel files. We also have the ability to push tables from your data model straight out to SQL, so you can sort of use Power Pivot or Power BI Desktop as a sort of a poor man's ETL tool and pull data in from various sources and then export it out to SQL or CSV. And then we've got a number of other file formats that we can read and write to. So we can read and write .dax files. They're just simply text that hold the text of your query that you've been authoring. You can open and save those. We can read Power BI performance data from Power BI Desktop, and load that in and view that. And we can deal with VPAX files, which lets you look at model metrics, and we'll have a look at that later too. So what can DAX Studio do? As I've mentioned, its primary mission in life is to execute DAX queries. But on top of just executing, we also let you profile them. So we capture internal events raised in the engine, and we can show you those events and help make them sort of easy to understand. We can also profile your tabular data models. On top of that, I'm a big fan of removing friction in software. So I like making things simple and easy to use and making the obvious thing the thing that works. So there's a bunch of other quality of life features, and you can check out the full list of those in at daxstudio.org. We've got all of the documentation online. So without too much ado, that is the end of the slides, and let's get into the demos. So I've opened up Power BI already in the background here. This is a report based on the New York taxi data set. So you may have seen that before in other presentations. So I've grabbed a year's worth of data from here. So there's about 10 million trips every month. So I've got 120 million records in here. It's about a 1 gig PBIX file. And you can see this is just an image for the landing page, just so often when I present this in Australia, people aren't familiar with how New York's laid out. So just to show people Manhattan and the Bronx, in New York, Brooklyn and Staten Island, Queens, and there's 2 main airports, JFK and LaGuardia, and out here there's Newark Liberty International Airport. So that's the primary way the New York area looks, and I show a lot of sort of heat maps of various metrics. So in the interest of saving time, I'm going to go ahead and turn on the performance analyzer and start that off. I might collapse this down to give us a bit more space. And so that will record our queries as we go through, so that'll give us some metrics we can look at. So on my first report page here, you can see 120 million trips. I've got another overlay of a map, and you can see the map tiles don't 100% line up, but it gives you a close idea of like Staten Island roughly lays out. So I've roughly taken a go at laying these things out so that they line up as close as I could make them. The projections are slightly different, which can be an issue. But yeah, this is just a map layer over an image. And you can see here, this is average fares. You can see that going out to New York and going out to the ends of Staten Island, and sort of rounds the further out you go, sort of the more expensive the fares are, which is what you'd expect. And closer into the downtown area here in Manhattan, there are lower fares. So we've got things like average temperatures and cumulative trips over the year, average single passenger fares. And if we go to our distinct pickup locations, you'll notice there's a slight pause here. So this is our issue. This is where we want to investigate, because we don't want people to be clicking through their report and then coming to a page like this that sits here. And bit of a spoiler alert, this is going to sit here probably for 20 seconds or so. There it goes, 16.5 seconds. So that's quite a long time to wait for a single visual to pop onto the page. You can see this is showing drop-off locations by the distinct number of pickups. So they get closer to red where there are more pickup locations. So as you'd expect, people come from all over the New York area and get dropped off at JFK Airport, and the same with LaGuardia Airport, and the same sort of as you get close into downtown. There's people coming from all over the place to go to these three locations. Whereas when you get out to Staten Island, there's probably only people coming from one spot back and forwards. They do trips back and forwards between home and the office. But this is a bit of an issue because 16 seconds is much longer. It's multiple times. The other longest was 2 seconds, so it's 8 times longer. So one of the good things about the performance analyzer is it captures the DAX query, which took the majority of time for this visual. So we can copy this query. Now DAX Studio is one of the tools that knows how to register itself, as long as you've got one of the recent versions. I think it has to be, I think it was partway through the 2.11 release. So we're currently up to 2.13. So if you've got 2.12 or 2.13, you'll have a DAX Studio button here registered with Power BI. And if you click and launch that, that will start up DAX Studio connected back to this data model. So you'll see we've got date, drop-off location, payment types. We've got date, drop-off location, payment types. So we'll go full screen now. So these are the same tables. I'm just holding down the control key and zooming with my mouse button. It's quite handy if the display is a bit small or if you're presenting. And you can see we've got tooltips. I can see how many columns. I can see the DAX name for this table. You can expand the columns here. If you hover over there, we show you a top 10 of the values with a number of distinct values. So there's 7 in this borough, drop-off borough. The minimum is Bronx, the max is unknown. You can look at the IDs. You can see they're all numbers, and there's 265 of those. So you can quickly get a quick overview of your data model just by using the tooltips. So we can paste in that query that we captured in Power BI. Again, I can zoom in to make that a bit easier to see. So this shows us we're using the drop-off location ID, so the map uses that to map to the different areas on the shape map. And then we've got a bunch of measures here. So typically, because we've got the one column and then a group of measures, we're going to expect that one of these measures is potentially causing the issue with the slowdown, since a lot of our other charts were quite fast. So if I run this, there's a good chance we'll hit the cache, and I can tell we hit the cache because that came back in less than a second. If we check the output, we can see it took 86 milliseconds, which is quite fast. So this hit the cache for Power BI, and you can also notice that there are 2 evaluate statements here, which means we get 2 result sets back, and DAX Studio is capable of displaying multiple result sets. I've tested with 15 or 16, so you will get scroll bars here if you get more than result sets that can fit here, but typically you only see a handful from Power BI, 1, sometimes 2, and often this is just for a grand total of the secondary result sets. So hitting the cache is generally not good for performance tuning. We really want to performance tune for the worst case scenario, which is when people make a hit the cache cold, and just seeing the output tab here is not great for measuring performance, because that includes time to for Dax Studio to be able to render these results. So typically what we want to do is put the client measurements aside and measure what happened on the server. So we can do this by turning on the server timings in Dax Studio. This will start up another tab down the bottom here. Server timings tab, that shows you a number of details, the total milliseconds, the CPU timings. So what we'll do now is we can capture the running of this query, but what we want to do is clear the cache. So what this will do, reach out to the engine and execute a query that will flush out the cache. So now that we've cleared the cache, we'll click run again. So this should take roughly our 16 seconds or so. You can keep track down in the bottom in the status bar of how long the query is running and how many rows come back. So you can also see the current server name, and this little copy icon down here lets you copy that to the clipboard, so you can copy that address and connect using other tools. So we can see that the query completed and took roughly 15 seconds. But if we switch over to the server timings, we can see that it took precisely 15.6 milliseconds, and we can see that the storage engine CPU spent actually 157 seconds of CPU time, so roughly 10 times. So it was extremely parallel. You can see it was running about 10 threads in parallel and using 95% storage engine versus the formula engine. So the storage engine is a multi-threaded engine that's capable of doing simple operations really fast, and the formula engine does the more complicated formula evaluations, but it's single-threaded. Therefore, typically we try and push things more towards the storage engine if we can. We can see that the storage engine issued 267 queries, and we can have a look at those. We can click on them. We can see this here over on the right is called XM SQL. It's not a true SQL. It's more of a text representation of the operations the storage engine performed. So it's sort of doing a equivalent of a join and filtering for passenger counts. So this is the grand total, and if you have a look in here, it's doing distinct counts for various pickup locations. And you'll see that it's doing a number of different queries for the different drop-off location IDs, and that's changing over time. So that's a bit of a worry, seeing that many for a query that returns 264 rows to see 267. It means it's scanning row by row pretty much. It's doing something in a loop over and over again. So unfortunately, there's no easy way of seeing which particular part of our query is slow. So what you would normally do is you would start to maybe comment out various measures. This gets a little bit involved with this query because it's doing a summarize columns over core, and then it uses this core variable here, and it's doing a top n over that. So I've commented out this single passenger distinct pickup locations, but then it's using it in the top n. It's also using it in this group by. So if I try and run this, it'll throw an error because I've commented some things out, but it's still trying to reference them. If you have a look down here, you can see that the error is on line 29. You can actually double click when Dax Studio sees these line and column references to an error. You can double click and it will take you to that location, which we can see is just here. So it's having trouble with the group by. So it sort of gets a little bit tricky to, all I want to do is look at the drop-off locations and use some of these measures and isolate which one of these measures is the problem. So there is an easier way of doing this in Dax Studio rather than starting with this query, because we know that drop-off location ID and some of these measures are the issue. There is a feature which not typically, at the moment it's still a preview feature, so you have to go into File and Options. And over in Advanced, you can turn on this query builder. Because I might turn on the benchmarks as well, because we'll have a look at that. The other preview feature is custom key bindings. So the key bindings gives you something here where you can override the defaults. That can be handy if some of these defaults don't make sense for you, or I know some of them clash with certain, if you've got a non-English keyboard layout, some of these defaults that we've picked are problematic, so you can come in here and rebind them. So if we go back now, turning on that query builder added this button to the main toolbar. And when we turn that on, that gives us a little drag area, and we can look up the drop-off location ID. So drop-off location ID, we can drag that in. We could have a look at the average fare measure if we want. There is a search here, so we can the average fare. And you can see that that search goes green to show you that this is highlighted. There's actually an option to keep the metadata search open. I tend to switch this on nowadays. That leaves this pinned open all the time so it doesn't bounce back and forwards. Modern displays are high enough resolution now that we don't need the vertical space as much, so it's not so much of an issue. So now that we've got this here, we could click run. Obviously, we've seen issues before. We'd have to click clear cache and then run. So if we clear that cache, if we click the run button down the bottom here, it'll run what's in the query builder rather than what's in this text window. So if I click run here, that took, you can see down there, that was 85 milliseconds. If we go over to server timings, you can see that was technically 74. It's a single scan, so it did that really fast. Single scan, that's the sort of thing we like to see. Reduce the number of scans in the storage engine if we can. So average fare is not our issue. So we can get rid of this now. Before we do that, I sort of know that the single passenger distinct pickup location is our problem. We could go through adding and removing all of these different measures to see how they perform individually, but it's this single passenger distinct pickup locations that is the interesting one. So let's get rid of that so it's not confusing. Hold down Control and zoom that in a bit. I should mention that in addition to just adding columns and measures, you can also add various filters. So you could search for the year 2016. Behind the covers, this is all just building a query. If you want to see that query, you can click the Edit Query button, and that takes you can see the references to drop-off location, you can see the filter that's being applied, and you can see the reference to the measure. So if we want, we could then start running this. We don't actually want the year filter in there, so I'm going to delete that. If I pop that query in, so that's just that one problem measure and the drop-off locations. The other option we've got in Dax Studio is this Cleocation Run button. So rather than continually clicking clear cache when I want to see the worst case scenario, I can click that. That will run the text that's in the edit window, but it'll do a clear cache first. So if I do that, that should run for our 15-16 seconds. So it's 10 seconds. And it's now just collecting all of the events, and see, there it goes. So that's just that one query is taking our 15 seconds, and you can see it's doing the 265 queries. And even though it is largely storage engine and parallelized, it does look like it's doing too much work for what it's meant to be doing. So the other advantage of using the query builder is this little edit measure button. So I can click that, and that's actually brought in the measure definition. So it's reached out to our data model, got the definition for this measure, and brought it back to this expression editor. You can see this is all on a single line. It's a little bit tricky to read. One of the other features that works both in the main window and in this expression editor is the Format Query button that calls out to daxformatter.com, so it'll send this text out, get it formatted by the daxformatter.com service, and it comes back. So it makes it a much easier to read. So now we can see it's doing a distinct count. For those of you familiar with Dax, you might know that doing a filter over the whole table is generally not a good idea, and this is probably the issue with our performance, because we're filtering the entire table when all we really want is just to look at the passenger count column. So the fix for this is fairly simple. We can just change this. Or in fact, I might leave. It's always a best practice when you're referencing a column to leave the table in front. So table and then column reference. And usually when we reference measures, we just use the measure name in square brackets. That sort of makes it easier to read your Dax and see that this is the column reference, and if it's just a name in square brackets, it's a measure. The other thing you may have noticed is that we've got bracket matching. The fact that this one is red means it can't find a starting bracket, so I have forgotten to delete a bracket. So now we can see that the start and end of the calculate matches up correctly. The start and end of the distinct count matches up. So if I click OK on this hasn't actually changed anything in my data model. This just overwrites the definition in the query. If we click Edit Query now, we'll see it's got a define measure at the start. So this definition of the measure is only used for this query, and it's not added back into our data model. Dax Studio effectively has a read-only connection to the data model. So we can, I might click the clear cache button just in case and click Run Query. And there we go. So that's gone from 15 seconds down to 94 milliseconds in a single scan. So that's a pretty good outcome. So what we can do now is we can copy this and paste it back into our Power BI report, and that's it will now be, how many times faster is that? A lot faster than it was before. So that sort of solves that issue. We also do have a query plan option that will show you a text view of the internal query plan that's generated by running this query. They are sort of academically interesting. This is a relatively simple, there's both a logical and a physical query plan of what's going on. I've actually talked to the product group about the query plans and was asking, are there any particular operations we should be highlighting here or things we should be looking out for? And the feedback that came back was that they pretty much, if they've troubleshooting performance issue, they will start with the server timings and pretty much look there. The query plans are quite low level, and often starting with the server timings and getting an idea of the number of scans and what's going on, and maybe having a look at the XM SQL gives you more of a hint than trying to dig into the query plans. So they're interesting, but at this point in time, not overly useful. So I might turn those off again. So one other thing that you might want to do, once you've got this sort of query down, if we bring it out here, one of the other preview features was the performance benchmarking. So typically, especially if you're running locally, I mean, at the moment I'm recording this session and there's probably antivirus processes running, and I've got Power BI Desktop and Dax Studio, and there's just a number of things that go on in the background. There could be Windows updates and all sorts of things going on behind the scenes. So it's often a good idea to run a series of queries. You'd probably want to run them, some doing clear cache to measure the cold cache performance, and then some just one after the other to measure how they perform with a warm cache, just to get an idea of how caching impacts on your query. So you can do that. You can click run, you can note these down, but the benchmarks figure will do that all for you. Benchmarks feature. Okay, so I've just restarted Dax Studio because it looks like there was a slight hiccup with enabling that run benchmarks in the options and then running it. So when you click on that button, we get an option for the number of cold cache and warm cache executions. Typically they're linked. You can unlink that and run different numbers if you so desire. I'm going to click on run. That's going to start a server timings tab so it can capture the detailed timings from the engine. It's going to do a cleocation run 5 times, and then it's just going to click run 5 times effectively. It's going to capture all of those detailed timings, and in a second we should see the results. So that shows up just as a normal table view. It shows you the average, standard deviations, min and max. You can see this is extremely consistent on this machine at the moment. It took 88 milliseconds min and 89 max. And when it hit cache, it took 2 milliseconds and 3 milliseconds. And that's pretty much, when you get down to single digit milliseconds, there's a bit of room for error in there. So a couple of milliseconds is really within the tolerance of error. You can go into details and get all of the breakdowns of the different, collecting all of the storage engine and formula engine metrics that you'd normally see in the server timings. And they come out in the results. You can Control A, copy and paste these into Excel if you want to keep the detailed stats. And that just sort of helps automate what was otherwise a sort of slow and tedious thing to look at. So the other option we've got up here in the Advanced tab is the View Metrics. So I mentioned back at the start we have this thing called VPAX files. So when you click View Metrics, what this will do is to issue a number of DMV queries against your data model. So all of the tabular engines have these dynamic management views. They tell you information about your data model. So there's some of these older ones like DM schema tables. If we run that, that'll give you a list of the tables in the data model, including some hidden tables and some of these internal tables. There's a lot of interesting ones. There's a few memory based. So discover object memory usage is one that the metrics uses a lot. So it uses a number of these DMVs. While we're on a slight detour, we also list all of the functions. So if you want to find if there's a function with the word text in it, there's is text, is non-text. You can search for date in functions with the word date in. You can hover over those to see the parameters for them, or if you double click, they come in and you can replace those with your own text. You could even evaluate that if we want. And if we use the table constructor syntax, that will run a single column with December 2017. So I'm in an Australian locale on my machine. So it's day, month, year. The other way around, as some people might be used to. So to get back to the metrics, if I click View Metrics, this now goes out, runs a bunch of those DMV queries, and reports back a whole bunch of interesting stats about our model. So we can see our trip table is far and away the largest. It's 1.3 gig in size. And if we, so this is the table size, so this is the same for every column, but we can look at the column size in the next one over, and that is, we can see here that our drop-off time and pickup time are taking up nearly half of the column size. If we have a look here, yeah, so it's 23%, 24% effectively, each of the trips table, and it's not much smaller for the percent of the whole DB. So nearly 48% of the entire database size is taken by the drop-off and pickup time. And you'll see there's 86,000 of these, which is roughly the number of seconds in a day. I think seconds, minutes, seconds. So just looking at this, you can get an immediate insight that this is a huge proportion of the total database size. And if I were to say, maybe I can get away with breaking it down to the minute, so that would get me down to 3,600 data points rather than 86,000. That would give me an immediate crunch down in the size of my data model, which means that anything that was looking at these times or related through the time fields would be scanning. The less data you've got in memory, the faster it can be to scan through, and it will reduce the processing time as well as the query time. So that would be one area where you could immediately look to get some savings both in queries and processing time. And potentially once you've got rid of these big tables, the engine can then look at other candidates and look at different ways of sorting the data to further optimize some of these other columns. So in addition to looking at this in a table view, there's also a view that lists every column. So we've got table-column name. You can see again these two pick-up and drop-off times coming at the top of the list. You can also look at the size of relationships. So everything here is pretty much related back to the trip table. You can break stuff down by petitions. Because this is a Power BI desktop model, there's only the one petition. And you've got a summary telling you the total size, what compatibility level it is, when this data was refreshed. So you have the option to export this, so you can export it, send it to someone else to look at if you want. They can then just import the metrics and that'll open up this view for them. So it's quite handy if you're a consultant or if you've got other colleagues on your team that are having issues. You can get them to send this VPAX file and you can have a look at the layout of their model and get an idea of what's going on inside it. So one other common sort of scenario that comes up is that if you're working with reports that are based off paginated reports. Paginated reports are one of the few client tools that can use parameters. So typically what that would look like is you might have a we might use an is parameter. So if I hover over here, I can see maybe we might want to look for credit card. If I can type. So if I want to look at maybe the pickup zone and have a look at the total amount for the pickup zones where the payment type is credit card, that will build a query like this. We can run that and that shows us. So typically if we wanted to treat that as a parameter in a paginated report, we would edit the query. Fortunately we can see there's a leading space in there. That's a bit of a shame. But we could type the name of a parameter in there. So this is typically what you might write in a paginated report, and then you would bind this parameter to a parameter in your report and everything would be good. But if we wanted to copy that query out and say we have an issue with a measure here, maybe when we hit a specific payment type, we'd copy and paste this query out. If you try and run this in pretty much every other tool like Management Studio, when you click run, it'll complain that there's no value for payment type. If you click run in Dax Studio, I've recognized the fact that there's a parameter in here that doesn't have a value supplied, and we prompt you for it. So you can type space cash, click OK, and let's just run our query. We click run again, and run for credit cards, and you can see down the bottom here it's now run the value for credit cards. So you can execute your query even though it's got an unfulfilled parameter text. So suppose you were editing a query like this, that you know one of the values is problematic, so that it is the cache value, but you want to run this over and over again. You can actually write out the parameter XML, and you can see if I cancel this behind the scenes, that's inserted this little parameter block with the name of the parameter and the value that's going to be inserted. So now that this is at the end of our query, each time we click run, it'll use that without prompting us, because it sees that there's now a value supplied for that. could type it in. You can change that and click run, and you'll see down here it's matching now that it's now running for credit cards. So that can be quite a handy way of generating this. So you might be sitting there thinking, why would I choose such a verbose XML format for just putting this name value pair in? So this is not actually something I specifically designed. This is actually an XMLA snippet. And what you'll find is that when you run SQL Profiler, and if you listen to query begin events and capture the queries coming off a paginated report, they will include this text. So it's possible to copy and paste a query like this, capture it out of a profiler event, or even easier is to turn on this all queries trace in Dax Studio. So what all queries will do is it'll start up down here and it will listen to any client tool that's connected to the back-end data source. So in this case, it'll be listening to Power BI Desktop. So if I click back on Power BI Desktop and click on one of the tabs we haven't hit yet, that should generate a query back to the data engine for this visual. And if I go back to Dax Studio, you'll see here is the query that was run. So in this case, because it's not a paginated report, you won't see any parameters. You can double click on this and it'll send it up to the editor where you can change it, edit it, execute it, whatever you like, performance tune it. So you can use this to capture queries against your Power BI Premium or against your Azure analysis services or analysis services on-prem. If someone's got an issue with a report or a particular thing, you could use Dax Studio and say just view the page, and you'd be able to capture the text here. We've got various filtering options. So if I jump back and click on a couple of other different tabs that show different visuals, you'll see they all get captured in here. You can look for durations greater than 60, and there's one query that meets that. You can look for DAX, MDX, SQL-based queries. You could filter by a database name. You could search for specific text within the query and just filter for that if you know there's a measure you want to capture. So you can do that all on there, and once you've captured everything, you can either stop or pause this trace. Pausing keeps the trace running, but just stops collecting any new events in the window. Stop actually disconnects the trace from the server, so it effectively takes that load off the server then, so it's not having to send you results. Though having said that, the all queries trace is probably the lightest one, so it just captures query begin and query end events. The end event captures the duration, and the begin has both the query and any parameters. So that's quite a handy way of using Dax Studio. So there are a bunch of other handy features. You may have seen that Power BI is now starting to standardize on the delimiters that it supports, in terms of supporting the, I don't know what's it called, for want of a better name, we call it the US UK version, where we use commas. So it's more common in English speaking language to use commas as a list separator and use decimal points or period characters between the decimals, whereas a lot of European nations use commas to separate the decimal part of a number. Dax Studio has an option here to swap delimiters. So if you're in a European locale, you'd use a semicolon where these commas are. So if we highlight that, click swap delimiters, you'll see that it's now swapped to using semicolons. So that can be quite handy if you've got maybe got text from someone suggested an answer on a forum, but they've posted it using the other delimiter syntax. You can drop it in Dax Studio and swap the delimiters over. So that works in addition to the comment, uncomment. We can click on something and comment it out or uncomment it. So we also have the merge XML button here. What that lets us do is to take the XML from parameter and push that straight back into here if we just want a hard-coded query. So in the past I've had other developers working that have massive queries with 15 parameters, so they became very hard to work with when you were trying to diagnose issues with, or try and pull them apart to see which measures or metrics or which columns are causing performance issues. So you could click merge XML and just inject that in just to get you a plain statement that you can then execute and run. So at the moment, because I've reopened this window, it's not connected to a data model. So in addition to being able to launch from Power BI, you can also just launch Dax Studio. And if you've got Power BI open, you can click connect and click on your data model. If you've got multiple data models open, they'll be listed here, and you can pick the file that you want, or you can type in the name of a analysis services server or paste in a Power BI premium XML endpoint or Azure analysis services in here. The top option here, Power Pivot only is available if you've launched from the Excel add-in. So there's a button we add to the add-ins toolbar in Excel where you can connect directly to a Power Pivot model, but you have to run that in Excel. So Excel doesn't expose any external connections. You have to be running in process in Excel. And on top of that, there's a bunch of advanced options, particularly when you connect to Azure analysis services. You might want to pick an initial catalog. I don't have a server running on this machine, so I can't show you, but if you drop this list down, it'll populate with a list from the server that's selected. You can also change the effective username or the role, which are very useful for testing roles, because it'll give you the results of your query, then run in the context of the effective username or the role. And you can do translation testing by running with a specific locale as well. So all of that's supported just with the drop down. And if you've got additional connection string parameters you want to inject in, you can add them in down here yourself if there's one, if these ones don't meet your requirements. So that's Dax Studio in a nutshell, and I hope you've enjoyed it. If you've got any ideas or have issues with Dax Studio, you can report bugs and request features. This will take you straight to our GitHub page where it'll open an issue, either a bug or a feature request, and you can put in there. I love getting feedback from people. I don't like getting bugs, but I like fixing bugs. So more than welcome to post either of those, and it really is with help from the community that we make this better. I only get time to sort of work on it in my spare time. It's not a full-time or a paid gig, so yeah, I welcome people's assistance, and there's a lot of features covered in the tool, so it's great to get feedback from people and ideas, and hear different ways that people like to use this, or different things people would like to see. So thanks very much for your time. I've just got a thank you slide to go. That's how you can reach me. That's my Twitter handle and my blog. My blog has a contact me page, or you can add comments to blog posts. I announce new Dax Studio releases and various other bits and pieces on my blog when I get a chance. And thank you very much for your time.